Hey guys, another quick one-take wonder video involving me rolling around on the floor for the benefit of two people who expressed an interest in this splitter assembly. I've just whipped the clam off, which gives us a good view of how this split is actually assembled. Basically, I made this from scratch. This is a plywood core, sort of 3D shaped core, which has been vac bagged in a multi-layer carbon fiber and carbon Kevlar laminate assembly. Obviously, a lot of the stiffness of that assembly comes out of the carbon itself, but as you can see, there's quite a bit of 3D profiling to the plywood core itself, and that 3D profile, when you do it smartly, gives a lot of three-dimensional stiffness to the final structure. So this thing is able to withstand my weight. I can stand on here on the edge of the lip, and that's a good 100 and something kilograms, which we don't need to talk about, without any serious deflection or deformation, which is pretty cool. The entire thing is mounted in three positions, I guess. One is at the front here. It's got a flange which mounts up and is mounted to the front of the original crash box assembly. The crash box is a pretty structural member. The OEM tow eye for the front actually mounts between the top and bottom flanges here, and if Lotus considers it strong enough to tow the vehicle out of a sand trap or out of a ditch, I figured I could mount a splitter across the bottom edge. So I've got a big flange, lol. I've got a big flange here, vertical flange, which has got some threaded inserts on the back side, and that's basically what attaches the initial central part there. Then secondarily, I've got these tension rods, which are mounted up to the aluminium chassis directly. So as I had the front of the car apart and the crash box didn't exist, I've had access up onto the front of the chassis, which has allowed me to put some eye bolts through the aluminium chassis itself, both here and just on the inside there. And with some aluminium tension rods and using just some plain old clevis pins, we've got an absolutely rock solid basis to support the outer elements of this. Now, the clevis mountings are using these nice carbon fiber or composite mounting systems. These are mounted in from the bottom up through the actual assembly. You can maybe see the profile just there and another one there. So it's going to take an awful lot of pull-through force to get these things to pull out, and yeah, as I said, I can jump up and down on the edges and it's pretty good. In addition to that, and this is where I get down on the floor, on the under tray here, I've mounted an aluminium angle across the front of the underbody section, and that angle allows me to have an overlapping joint. So I've got the splitter mounted on the top side of this aluminium angle, which prevents it from being pulled down. There's no actual secondary fasteners there because it's all wedged in pretty tight, but yeah, that's not going anywhere. In terms of the profile and the aerodynamics of this thing, there's, I guess, four major components. One, you've got the dam effect coming out, the extension out the front of the car, which captures the downward force from the air accumulating from the forward direction, tries to go downwards, creates a downward force on the front, extension element. Then we've got the aerodynamic elements of the diffuser. So I've got two diffuser effects here. One is I've got a diffuser which exits into the wheel well. There's a bit of a dead space. There's not an exit out of the wheel well. Well, there is if you consider the vents that go up over the top. But if we just ignore the messiness of the airflow that's here, what I've got is basically a small diffuser. Now let's get some light in here. Yeah, smooth. So we've got a small diffuser section here which discharges into the wheel well. It's probably around a 10-15 degree angle. What's more significant, what's going to have a bigger effect, is this entire section here. And the lights fall over. That's great. So the front of the diffuser here generally is a big flat section. If we consider all of this one big flat plane, and this sits around 20 millimeters lower than the overall underbody of the car. Then we hit a transition zone from here where it enters a diffuser. And this diffuser basically a volume expansion over a 2-degree incline, which then ends up mating flush with the bottom of the floor and continuing out the back. This 2-degree incline basically generates a large negative pressure zone at the transition. So in addition to the downward force of what's coming from the top, which is basically a dam effect from the front of the car, we're creating a secondary negative pressure zone in around this area at the throat of this, albeit small but still diffuser element. So diffuser into the wheel wells, these should create a negative pressure zone here. Large lower profile diffuser in this area, which would create a low pressure zone immediately on the underside of the high pressure zone from the top. And finally, and this is something which is basically just shotgunned, and we'll see if it actually works. I wanted to achieve a vortex down the side of the car. 2 sensors, I guess. I wanted to seal the bottom of the car to improve the effects of the actual the rear diffuser. So I wanted to be able to create a wall down here, and also not on this side but on the other side I've got my water to air intercooler core. The air intake for that is around this region here. Can't see it from here. So we want to keep the air connected to the side of the car and hopefully get it to turn into that cooling duct. So this is a turning vane which keeps it's a dam and stops the positive pressure that's generating here from the dam effect from slipping out over the side, or at least not immediately over the side. When it does slip over the side, it will start to curl. So basically it comes into here, slips over the edge and goes into a spiral, and that's your vortex generation. So this single turning vane should spit me out a vortex which goes down the side. I'm also curious to see what this horizontal component here does, because if we turn it sideways, we're going to end up with basically the same thing. You should get a peeling vortex off this surface. The air's going to flow from here off the edge. So I don't know if we're going to end up with 2 vortices, or we're going to end up with one big vortice, or we're just going to turn into some massive mess. I've done some actual physical testing of this with a Karcher, just looking at the air and fluid flow over this, and it seems to spit off just one big vortex. I guess that's another we'll suck it and see moment once the car's actually running. So yeah, that's the splitter. That's the overview from the front. You can see the diffuser right down the back. Yeah, that's it. See ya.